Good afternoon, everyone. Thank you all for joining um, the January edition of the West Watch. My name is Dan McAvoy, and I'm the regional climatologist at the Western Regional Climate Center. I think we're just going to wait another minute or so to see if others join. We're already at 2:02, so I'll give it about 30 more seconds and then get started. All right, I think we'll go ahead and get started. So I just wanted to start off by providing a bit of background for those that haven't attended the West Watch before or haven't attended in a while. This is a monthly webinar, or right now it's a bi-monthly webinar series that we're bringing together primarily NOAA staff, but also other partners from around the region to share information about climate observations and also the impacts that those events bring across the Western United States. The webinars cover recent climate and weather events, and then we also cover coastal and oceanic conditions. And a little bit of housekeeping before we get started here. We try to have some time for Q&A after presenters, but we do ask that you put your questions into the question box, which is located on the go-to panel there. And again, hopefully we'll have time for that Q&A. These sessions are being recorded. Hopefully this one is recording. The go-to is brand new, so I don't know if that started recording. But then these are posted to a Westwatch website afterwards. And you will also should get a post-webinar survey, and we do really appreciate the feedback as it kind of helps us figure out what we're doing good and what we can improve upon in the future. Today we have a great lineup of speakers who have provided information over the past several years on our climate and oceanic conditions. I will be presenting the climate briefing, and then we'll have our panel of presenters from IUCE. We'll have Jan Newton from the Northwest, and then Alex Harper from Central and Northern California, and Clarissa Anderson from the Southern California region. And I'm going to jump right in with the climate update and outlook as we have a webinar chock full today as usual. So I'll just go ahead and dive right in. So I want to talk a bit first about how things are looking in terms of water year precipitation. So our water year begins on October 1st and runs through September 30th. So we're about 3.5–4 months into the water year here. And so these two maps here are from a tool called Climate Engine, and the one on the left is showing the percent of average precipitation from October 1st through January 18th. And the map on the right is showing the actual values in inches of total precipitation. And a few things stand out here. The thing that really stands out is the far southwest, including Southern California, Southern Nevada, Western Arizona, where they've seen less than 5% of average precipitation since the start of the water year. And of course, this has played a factor in the LA fires that happened about 2 weeks ago. I do have a few slides later on to get into a little bit more detail about the climate context related to those fires. But first, I wanted to touch on the larger scale picture here. So the whole Southwest has been very dry. There's actually a large area, less than 25% of average. And so that's really the big picture in terms of dryness. But there are other areas like the Northern Rockies and parts of the Cascades that also are below average for the year that we shouldn't overlook those areas. And then we have some areas that have seen above average precipitation, including much of Oregon, Northern California, Eastern Washington, and eastern Colorado and northeast New Mexico. But if we look at the map on the right that shows the actual values of precipitation in inches, you'll see that actually some of those places in California, Nevada, and western Arizona have seen no precipitation since the start of the water year, and a big area has seen less than 3 inches. So again, that extreme dryness in the Southwest is one of the big stories. And in terms of temperature, so now we have the same time period, water year to date temperature, departure from average on the left here. And all the reds are above average and blues are below average. And so pretty much the entire West is showing above average temperatures, some areas 4 to 6 degrees Fahrenheit above average for the water year so far. There are some isolated areas of below average. Those areas are much less spatially than the above average. One of those areas is along the far Southern California coast, which has to do with fog and persistence of marine layer that has led to actually some below normal temperatures along the immediate coast. And then the map on the right is a drought index, the standardized precipitation evapotranspiration index. This looks at the difference between accumulated precipitation and accumulated evaporative demand. And so what this map is showing, the reds, the darker reds are more severe drought conditions, and then the blues are no drought or wetter conditions. And this is the same time period, October 1st through mid-January. And we do see that Southwest area again stands out as showing a water year drought, but also fairly severe water year drought conditions in that northern Rockies area of western Montana and northwest Wyoming and parts of Idaho. So we are getting into the middle of the winter and snowpack season here. I wanted to touch on that. The map on the left is the snow water equivalent percent of median for the end of the day yesterday, January 20th. The blues and greens are above average. The orange, browns, yellows, and reds are below average. And based on that precipitation map I showed earlier, we see that that has led to a pretty bad snow drought in Arizona and New Mexico, where pretty much that entire region is less than 50% of average. And in some cases, a lot less than that with no snow on the ground in some of these locations. I've also included in text so the map on the left is all from the SNOTEL network, which does not include the California Department of Water Resources stations. And so I've included the numbers there from the north, central, and south regions of California. And the big story there that you can also see in the map is that as you go from north to south, you go from pretty wet to very dry. And so the southern Sierra Nevada is currently at 54% of average snow water equivalent. The map on the upper right shows the precipitation percent of average over the last 30 days. And this is really showing the drying trend that we've seen extend a bit further north into the central Sierra Nevada. But there's also been some pretty severe dryness in northern Washington, northern Idaho, northwest Montana, and parts of Idaho. So all leading to these percent of normal snow water equivalents starting to go down pretty quickly in some of those areas, and particularly in the yellow and brown colors there. And so if we look at the overall drought conditions now presented by the latest U.S. Drought Monitor map that was released last Thursday, we do see that developing drought in the Southwest, in particular Southern California, coastal California, Southern Nevada, Arizona. Those are all places, so the map on the right is showing the change in those drought categories over the last 3 months. And so those are all places that have seen drought developing and increasing. Other areas of drought, again, include that Northern Rockies area. That's persisted for a long time now, probably over a year for some of those areas. But we've also seen some drought improvements and amelioration in places like Washington and Oregon and parts of Colorado and also New Mexico, which is a good thing to be talking about. So I did want to put some context into the Los Angeles fires. I want to give a brief overview of the climate context around the fires, but first I just want to say it was a really tragic event, and my thoughts are with the community and everyone affected by these fires. And so these statistics here are from CAL FIRE, and they now show that the Eaton and Palisade fires are now the second and third most destructive fires in the state's history. But another thing to point out there in terms of acres burned, they're not tremendously huge wildfires in terms of the largest fires in California's history. But of course, the factor there is how close they are to the densely populated Los Angeles area. And so there's a lot to cover. There's probably going to be lots of webinars and papers and publications in the future documenting all the factors um, related to this outbreak of wildfires, but I'm just going to cover some of the pretty straightforward climate and weather factors related to the event. Those three primarily being a very long stretch with no wetting rains for the Los Angeles area, the extreme Santa Ana wind event, and then how that combined with dry fuels and vegetation with low moisture content led to this rapid spread of the wildfires. So in terms of precipitation, I showed in map form that the LA area was less than 5% of average for the water year on that map before. And so this graphic right here is showing the accumulated precipitation for the downtown Los Angeles station with data going back to 1877 since October 1st. This brown line is the normal or average, which is around 6 inches. Water year 2025, you can barely see the trace. So the total for this year is 0.16 inches, and that's the third driest on record since 1877. But if you look at the consecutive days with less than 1/10 of an inch of precipitation, it's tied for the second longest streak at 260 consecutive days, and that's still going on. The longest was in 1963 with over 300 days. And so if you look at that 0.16 inches of precipitation for the water year, that all came in November, and it came in 4 separate days, the most in one day being 0.07 hundredths of an inch. And so no big wetting rain so far this season is one big factor in wildfire danger. And so the other big factor are the extremely dry fuels and vegetation. This map on the left is the live fuel moisture graphic that was put out by the predictive services. It's hard to see, but there's a dot that I circled there that's right around the 60%. And that was a January 6, 2025 value, which is right around that critical threshold for fuel moisture. And it's about the same level it should be at kind of late summer into the fall when things are typically at their driest. So no wetting rains led to no wetness in the vegetation. And then the graphic on the top right is showing the modeled dead fuel moisture. This was basically showing this blue line going down to near record lows right before the fire started. And then on the bottom right is the maximum wind gusts on January 7th from that extreme Santa Ana wind event. And so what we're seeing here around where those fires were some gusts in 71, 83, 85, so gusting 60 to 80 plus miles an hour. I believe there were a few RAW stations that we recorded wind gusts over 90 miles an hour. And so this combination of extreme dryness, dry fuels, and then not just the magnitude of the winds, but the wind event was very prolonged, lasting 12 plus hours, closer to 2 days. And that really fueled the spread of this wildfire event. And I want to end with the briefing of the ENSO update and the seasonal outlook here. So as of the update from this morning, there is a La Nina advisory, and this is all from the Climate Prediction Center. They have finally announced that La Nina conditions are present. It's been developing for a while. And so the sea surface temperatures in the equatorial Pacific are below average, although you do see some areas of yellow in the far eastern part there. And so this La Nina is expected to persist through February into the spring, with a transition to ENSO neutral likely by late spring. And so if you look at these latest actual departures from average for the sea surface temperatures, we see the Nino 3.4, which is the index that is commonly used for La Nina or El Nino, is at negative 0.6, so just below that La Nina threshold. Some of the ones in the eastern Pacific are a bit warmer, closer to 0 or average. And so the forecast here showing the seasonal forecasts on the top left are the probabilities of the ENSO or the El Nino, La Nina, or ENSO neutral. And we see for winter heading into spring, there's high probabilities of staying in a La Nina. and then again transitioning into those enso-neutral conditions later in the spring. And the bottom right shows the magnitude of the event, not expected to be much more than a weekend event by any of these models. And so that's where we currently are right now, and that's expected to continue. In terms of the temperature and precipitation outlook, so this is the outlook for February, just the monthly outlook, indicating higher chances for below normal temperatures in the north, and the opposite of that, higher chances for above normal temperatures in the southwest. Not an incredibly strong signal for precipitation, but there are some signals showing above normal precipitation odds for the Pacific Northwest and Northern Rockies, which would be good for some of those drought conditions. But unfortunately, there isn't any signal for above normal precipitation in Southern California. In fact, it's showing lower odds of below normal precipitation for that region. And this final map here is showing the seasonal outlook from February through April. And it's actually a very similar pattern to the last map I showed, which continues to show dry for the Southwest and potential for wetness above normal precipitation for the Pacific Northwest, and equal chances in between there in that white shading. So I will end with that and pass it over to our first speaker from IUS, who will be Jan Newton. If you're able to share, maybe I'll stop sharing.
Okay, let's see if I can make this happen. Hi, everybody. Jan Newton from NANUS. And okay, and then I'm going to stop my video because you don't need to watch me. So here we go. Okay, back to the PowerPoint. And away we go. Thank you so much, Dan, as always, really interesting. Okay, so I'm going to be the first of 3 report outs from the regions, so thinking about our regional conditions. NANUS presents a lot of data products, and one that we found useful is the false color imagery of temperature anomalies, and being able to put the West Coast and specifically the Pacific Northwest into context. Here you see the false color image of warmer than average temperatures in October, and then November, and then December. And in none of those views did you see the West Coast, or specifically the Pacific Northwest, looking very hot. And so one of the things that we also have been presenting is this marine heat waves tracker imagery of where the marine heat waves are now. This is as of January 17th. And you see that in the Pacific Northwest, there is nothing to note currently. I also went to the NOAA's California Current Marine Heat Wave Tracker, and you can see the map on the right saying basically the same thing, but they've got a really nice analysis where for each of the states or regions, they show over the course of the year the marine heat wave percent cover and intensity. And you can see in Washington State, Oregon looked much the same, that there was a significant marine heat wave event in the fall, but that has really shut off. And you can see that on an annual average, since this is our kind of the end of the year, beginning of the year, we were pretty typical from climatology, but this event set us up, and that amount continued. It didn't rise further because the marine heat wave ended. So that's basically the temperature signal. This is now similar water temperature anomaly based on a zoom in using an Oregon State University MODIS satellite product. Again, these colors are kind of muted. There's not a dark red or a dark blue. And so really not much of a temperature signal currently in the last 3 months. These are monthly averages, I should note. And all of these are available on our website through the climatology app.
Hi, Jan. I'm sorry to
Yes.
interrupt, but your slide disappeared all of a sudden. I'm not sure why. I'm sorry.
Wow.
I
You're
saw
right. I'm not
them.
sharing anymore. I'm not sure what happened. Thank you for letting me know, Dan.
There it is.
Okay,
Thank you.
thank you. Okay, that's the slide we were looking at. And so now, done looking at satellite, we're going to look at the buoys. And this is a buoy about National Data Buoy Center, NOAA buoy, 300 nautical miles off the coast in our neck of the woods. And you can see that through the end of the year, it went to normal. And then it gave up the ghost. And so it's no longer recording, unfortunately. It's been a bad fall for buoys, and we'll get to that in a little bit. Looking up and down the coast of Oregon and Washington, we see much more variability, as we always see near the coastline. But in terms of temperature anomalies, nothing really much outside of the plus or minus 1 standard deviation, a little bit in the fall, but that seems to have come back more towards normal. So nothing too outrageous in temperature signals. And the add-on is for the first part of this year. So these little graphics there. Okay, now coming into an inland sea in our neck of the woods, Puget Sound, here are the temperature anomalies. These are profiling moorings, so you're seeing the full water column. Not all of these buoys have the same depth. That's noted on the y-axis for each of the buoys. And if you're not familiar with the region, it sort of doesn't matter. The thing I want to convey is that we're seeing warm temperature anomalies for all of these. And specifically, this diagonal signal is actually an oceanic intrusion that happens in the fall. And we really see that it's warmer than average based on a 14-year climatology. Here's the salinity. Again, saltier than average and consistent throughout all the basins. Here's that oceanic intrusion, which, starts at depth and starts earlier in August. And here is dissolved oxygen. We're seeing a very mixed signal. I have a hard time interpreting this plot because there's so much variability, but all to say that we did not see severe hypoxia. We can see that oceanic intrusion as it typically does, but especially this year brought in a lot of more oxygenated water. And there's one place, Hood Canal, that we worry about. This appendage off of the Salish Sea or Puget Sound is called Hood Canal. It's a long fjord-like appendage and often is host to severe hypoxia. Hypoxia is colored here by the white fading to blue colors. And you can see for Hoodsport, which is this buoy, and then for Toano, which is almost to the dead end of Hood Canal, there was hypoxia, but it didn't develop very much, and though we have a little bit of missing data here. But the best thing is that it didn't poke through to the surface, and when it does that, that's where the fish can be jeopardized, and we see fish kills because they don't have anywhere to escape. They don't swim down, and if they lose their refuge at the surface, then they succumb. But anyway, that suffice to say that it was a good year for hypoxia, and we ended the year not being sensational for temperature. Moving on to chlorophyll from satellites. So ocean color, you can see these are false colored for green being more than average and blue being less. Typically these plots look mostly blue, but you can see the blooms, which of course are very patchy. And we see in all of the months, but particularly in October and December, offshore blooms up and down the coast. But what we have learned from the ORHAB project is that there really wasn't much in the way of pseudonychia, so the toxic, harmful algal bloom. So again, a good year in terms of that threat. All right, so what was noteworthy? And so shout out to CDIP and Ross Timmerman for sending us this composite. There's been some storms in December, really sensational storms. And so here you see this extratropical storm activity in the East Pacific continues to generate elevated winter wave conditions. And so there's the CDIP network along our coast, and What number I look at is H max, the maximum height, and we're seeing 13 meters, 12.6 meters, 10, basically 11, etc. And 14 down in California. Um, 13 meters, that's a really big wave. And so this was from the December 12th through the 15th event. This is just blowing this up, although you could probably see it just as well, and I forgot to animate this. But anyway, let's shift our attention now to this snapshot, again from CDIP. This is basically the pre-Christmas December 22nd to the 24th, so um, solstice to Christmas Eve event. And again, we're seeing these very large numbers, 10.5, 13 of the wave height maxima. And so we had the bomb cyclone. We didn't just have one storm, we had several. The pressure drop was historic, and we had 13-meter waves. This was a major problem for some of our assets along the coast. John Mickett, who's the PI for our Cheba buoy, said, well, you know, they do this engineering analysis of wave conditions, and we scoped for 12 meters, not 13. And so several of our assets went on a walkabout, and really want to give a major shout out to the Coast Guard, both in Canada and the US. And so we've had some happy stories. And so the first one is our partners at the Columbia River Intertribal Fish Commission had a plume buoy that moved a couple of kilometers in November. And then during the bomb cyclone, it moved another kilometer, and it was closer to a shipping channel. And so the Coast Guard cutter Elm was able to go recover it. And that's the hooray. That's a picture from CritFic of their buoy recovery. So that's down Astoria. So that's like where the Columbia River plume empties out into the Pacific Ocean. Farther north off La Push in Washington, the Cheba buoy that I mentioned earlier, it withstood the bomb cyclone, but it broke loose afterwards. Fortunately and interestingly, when it drifted north, it drifted actually into the Strait of Juan de Fuca. And then the Nia Bay Coast Guard helped tow it closer to shore. And the Makah tribe's fishing vessel, Alyeska, was able to pluck it out of the water with so much of its equipment intact because it's got a lot of mid and deep water column assets. And then lastly, I've been involved in a program called Backyard Buoys, working with tribal partners out on the coast. And one of the two Quileute tribes' spotter buoys went adrift, and it wandered around. But the PI for the project, Jennifer Hagan, who works for the tribe, was able to get in touch with the Canadian Coast Guard, and they were able to recover the buoy off of Vancouver Island. And so instead of being sad stories, these are happy stories. To summarize, I'll leave it there. I've got 40 seconds, but we don't seem to be having too many issues with temperature or hypoxia. We're seeing Puget Sound being warmer and saltier because it is retentive. Didn't see major problems with HABs, but the storms definitely put us on the chase. So with that, I will say thank you very much and pass the baton to Alex Harper from Senkus. All right.
Thanks, Jan. And hopefully, Alex, you're able to share now. Sorry about the technical difficulty. And whilst Alex is sharing, just a reminder, if you have questions, to please put them into the chat, as I think everyone is in listen-only mode. Thank you. Oh, Alex, we see your screen and we see your camera, but we can't hear you. Or I can't. we could. I still can't hear you, unfortunately. Um, saw thumbs down, also meaning we probably they can't hear you. We
I'll
could
try to,
go to. Oh, go ahead, Nicole.
thanks, Dan. I'll try to provide a call-in number. So
Okay, and
just
I was
one
going to
moment
say
and I'll put
we.
in the chat. And what do you want to transition over to James?
Yeah, so why don't we go to Clarissa and James, and then have Alex come on after them to keep it moving.
Okay, tell me if you can see this and hear
Um,
me.
yes, I do
Yes and
see
yes.
your. Oh, there we go. Perfect.
Okay, all right. I'll try to loop back to Alex in a minute. I will jump down to Southern California and, as in the past, share this with Jim Behrens from CDIP. A couple things I just wanted to point out that are, I guess, not exactly current events, but just things to be aware of. For those of you interested in the long-standing kind of decadal review of the Marine Protected Area Network, um, a pretty stellar group has come out with a paper in conservation biology. This is led by Josh Smith at NCUCSB that really breaks down how we can evaluate the efficacy of MPAs. And for those of you interested, I wanted to point you to this paper. I thought it was a pretty heroic effort to pull together this much data and to really evaluate this and to find that age and habitat diversity are really strong predictors. We look at this through the lens of protection, and we want to know what those protections afford. That can be a complicated question. So yeah, this is one little thing I wanted to point out. And also in the near future, we will have some new observations at many of our sites, thanks to investments from both our bilateral bipartisan infrastructure law and the Inflation Reduction Act. We're starting to really outfit our sites with new sensors. So we will have more pH and oxygen coming up at Stearns Wharf in Santa Barbara. And we now have some sensors at Scripps Pier that give us more of the biological setting and turbidity in the form of things like dissolved organic matter. One more thing to highlight that has come out, we did put our harmful algal bloom bulletin out for October. We're still a couple months behind on the winter ones, but this relates to some of the big events we talked about in our last meeting and how there had been some spillover of sea lion stranding events into the fall, but largely most of the domoic acid problems that we saw in the fall were connected to the Dungeness crab fishery opening. We're not seeing a lot of harmful algal blooms right now, so I won't be getting into that today. We do have another seabird report out that we post, but this is also, of course, posted by Farallon Institute, who creates this report. It's critical for understanding how these sentinel species change with time and certainly change with things like low frequency variability, things like El Nino. So we are talking now about that transition to La Nina. There is an index that rolls up a lot of these things. We've all talked about it, particularly me, Henry, Alex, in previous webinars, that this rolled up meta index gives you a sense of how often biological response is relates to things like this low frequency variability, in particular certain sentinel bird species like murres. I think there's a whole bunch of different species in the near shore that really do react to El Nino events. We're moving into this La Nina zone. You can really see it more impactfully, at least in terms of the numbers and the index in Southern California versus Central and Northern California. So we're tracking that in the physics, and soon I'm sure some of the biology in Southern California. The spray glider lines give you cross sections like this of what it looks like from the surface to about 500 meters depth on a cross-shore transect. That transition to La Nina is pretty clear here as you see more of a cooling in the near shore, and that's dissipating a little bit as we get into January. Now that we're truly in a La Nina, we're seeing it a little bit less so in those glider lines. But we are seeing it in other places like our shore stations. And one way to look at this too, to get a kind of better sense of how this stacks up with the different indices for El Nino at the equator, is to look at a Hufmüller diagram for the glider data, which you're seeing on the left, where those warmer anomalies have shifted into cooler anomalies in the last, the turning from fall to winter and into 2025. And then looking at in terms of a time series plot for just the 50-meter temperature for Southern California, and then the ONI, the Oceanic Nino Index, on the right plot, that coupling we're often so used to is quite clear here as we move from La Nina at the equator and also into La Nina in Southern California. However, I want to point out that that blue line, which is the Southern California temperature index, is slightly diverged from the La Nina dip and is a little bit elevated, indicating some local warming that may be not exactly an extra tropical source of warming, and something that we've been interested in for quite some time as we talk about marine heat waves. At our shore stations, you're seeing that cooling that starts in about August, September, moves into the fall, some extreme anomalies in November and December, and now in January at Scripps Pier. And this is coincident also with model output that NOAA creates, such as the West Coast Operational Forecast System. And then you're seeing that animation on the left. If you watch that as we moved into December and January, you'll see bits of cooling more in the bight than in north of Point Conception. And that is reflective also here in our shore stations. I'm just going to let that run. Okay, that ran. Now we can move on. Just making note, of course, that we've had this extreme disaster of these fires. It's been talked about already today. But clearly these satellite images tell us just how impactful fire events like this can be on the ocean. That plume has quite an extent out into the Pacific, and NASA is doing a lot of work, even with all of the pain and hardship that their employees have. They've been doing great work, getting a lot of new imagery and different types of imagery and analysis online. But out on the coast, our oceanographer friends have been out there toiling away on the Cal Coffee cruise that coincided with this tragic event. And they've tried to take this opportunity to understand what those impacts of ash will be on the marine ecosystem. We do know that we can get things like phytoplankton blooms stimulated by the phosphorus and nitrogen in ash. So we will be following up. Those out there are doing all they can to revisit sites, collect ash and debris, and then plan follow-on cruises with the Orange County and LA sanitation districts to evaluate the effects of this bloom, and I mean not bloom, of the fire. I suspect I'll be back talking to you about some kind of a bloom. We know we've seen this in the Santa Barbara Channel before, so it's fairly expected that there will be some kind of a biological response from the fires as they continue. And also, I think many of you know we've got a few in San Diego right now, and we even have staff at SCOOS who have had to run home today because they were in an evacuation zone. So the troubles continue. And lastly, here in our Armageddon tour, we have had some sorry, I'm having a hard time talking today, sewage spills just off the coast, both in Venice Beach. This one started in Bayona Creek, and then also one in La Jolla Shores. Our sensors down here that from the lab of Ascend at Scripps have caught some interesting inflection points there related to that sewage spill, particularly in the fluorescence and turbidity. And you can see some of the more recent spikes in this time series are connected to that most recent sewage spill. And I think this is where I shift over to Jim.
Thanks, Clarissa. All right, I think we successfully did that. Just a quick update from the world of CDIP. Jen already brought us up to speed a bit on the historic events that we've been measuring and issued some bulletins in the fall. The one that stands out from the climate record perspective in particular is that December 22nd, 23rd, 24th event. Going back to the earliest days of CDIP buoy stations in the early 1990s, this was the strongest long period, and by that I mean 22, 25-second period wave event that's on record now. So this is we're looking at the return time expectations, and this is sort of a century type event, and obviously there's a major impact on infrastructure that showed up in the news, and the Eddy Big Wave Invitational was run in Hawaii. This was all thanks to a fetch that was extraordinarily long across the Pacific Ocean. Just it seemed like two systems kind of lined up, and just the pure fetch length was unlike anything that we normally see. And so looking at the climate records in Northern California, the Humboldt Base Station was one of the strongest wave records from that event. And then you can see that we've had a number of these fairly active storm events in the northern part of the West Coast. And then down in Southern California, however, we've only had just a little bit of energy kind of leaking through, very little local storm activity, along with the drought. Next slide, please. I don't think I'm able to. Yeah, there we go. There we go. And then just a zoomed in view of the Monterey Bay area. This is one of the locations where we've been building out our array a little bit in recent years. And this is a close-up of the HS, the significant wave height from our CDIP coastal wave model at this in low res mode at this part of the coastline. And a couple of our stations indicated there's the Soquel Cove, there's the Pajaro Beach area, where we have two buoys very close to each other that are measuring very different wave heights simultaneously. That's why they're sitting there side by side. And we're about to install CDIP 156 to help with understanding the locally driven seas component. And so this is a location with lots of new and detailed data in the coastal wave domain. And then just a little note over there on the right, when those ultra long period swell readings were coming through, our automated processing was rejecting them. Normally when we see this kind of thing, it's because a boat has hit the buoy or there's some sort of sensor failure. So those ultra long period records actually didn't get transmitted in real time to the NDVC database. So if you're looking back on this, come to our CDIP website. Next slide, please. And then just a reminder, we're measuring the temperatures, and this is similar to what Jan was mentioning up north at Clatsop, and then down here in Southern California, things have been chilly. And I will hand it back to Clarissa. Thank you for your time.
I think it's time for Alex. I'm going to try to unshare, or do I even need to unshare? Let's see. Stop sharing.
I guess I should say, sorry, one last thing I'll plug. We're
Can you hear me?
collecting letters of support at this point of the year. So thank you to those that have already responded. And I'm sure some of you on this have been hit up already. And if anybody has not been approached for a letter of support for CDIP and would like to, then please reach out.
Can you hear me?
Yes.
Can you hear
Alex.
me now?
Yes.
Oh, gosh. Thanks.
Let's try this again with Alex.
Sorry, Jim, to cut you off there at the end. I was feeling a bit nervous that
But I will say I don't see your screen yet, Alex.
Okay, let's try this.
There it is.
We're on our way. Sorry for the hiccup before. Get into presenter mode here. How's that?
I see your presenter mode right now. I don't see the
Okay.
full screen mode.
I think I'm on the wrong screen here. Let me see if I can.
Alex, if you go back to where you were in a presenter mode, and then up at the top, there's something that says display settings, and you can say duplicate. That usually takes care of it.
And then display settings. I don't see that.
No, go back to put it in slideshow where you had been. Yep, and now up at the top it says display settings. Yeah, duplicate slideshow.
That
There
it?
you go. You did it.
Oh, geez. Sorry, you all,
Good.
for the hold up. Are we good? that Can I
Yes.
progress the slides? All
Fire
right,
away.
here we are. Here we are in my neck of the woods, Central and Northern California. It's been an exciting season for all of us along the West Coast, as you've been hearing. And so to kick things off, to kick the holiday season off here, we had the Santa Cruz wharf partially collapsed into the Pacific Ocean and set sail for about a day. You could see some construction workers who were out there at the end of the wharf sort of repairing things. It wasn't open to the public, but still a worrying situation. And we were certainly getting pinged by lots of partners from locally in San Francisco and trying to look at our data systems. You know, part of this presentation is a bit of a celebration of leveraged observing systems, and that, we've had trouble keeping many of our systems in the water and operating through these winter storms and swells, and so having the network to pull from. So I'm showing here some of the data that Jim at CTIP is working to support and maintain. Also his significant wave height model is a bit zoomed out of what he showed. And then in the bottom right, sort of across the bottom, is a water level sensor that's been deployed, I think, by the city of Santa Cruz, that was on the wharf that survived the swell and had some pretty significant data hits around the December 22 to 24 event. But it's not sort of all bad news, at least for this pro surfer out of Santa Cruz who had the ride of his life up in Mavericks. And again, just a nod in celebration of CDIP and the wonderful work they do to help us understand these significant wave events and also the importance of wave period, which I'm learning more and more of. Another sort of item of news out of the region, the Dungeness crab commercial fishery has opened for the year. So now the state is fully open as of January 15th. It was partially opened previously earlier in the year in zones 3, 4, 5, and 6, and now zones 1 and 2 have been open. It's my understanding, and so the Dungeness crab fishery is the most valuable in the state and has undergone significant delays due to risks of whale entanglement recently. In recent years, and then prior to that, challenges around toxicity from harmful algal blooms and meat quality. And so we're happy for this fleet to be out and doing what they love to do. Getting into some ocean temperatures. And so this is from our West Coast Ocean Forecast System. The GIF at the top is the look back across the year of sea surface temperatures. So here we are in January, and then going into the spring. Summer is hot, and the red sort of creeps all the way into shore. And then this recent cooling sort of down the coast. And I pulled these snapshots of January 2024 and January of this year to show that things are quite a bit cooler this year than they were last. And we talked about some of the climate drivers behind this. Delving in a bit deeper on ocean temperatures. And so these are some of our coastal moorings from NDBC and CDIP across the region. I might note this, and so these are anomaly plots where sort of the more red, the longer the red is, more anomalously warm the conditions are, and then the longer the blue, and where you see blue, it's anomalously cool, and it's based on sort of the record of data from these points. And so you see up north, we had this like pretty cool late September into October period, and then warming sort of in December, and then just recently ticking cold again up off of Eel River and Humboldt. The CDIP buoy 157, which we've looked to a lot for these wave data, is also collecting temperature data, and so demonstrating sort of cool temperatures. This is over the past 6 months, and similarly down south off of Santa Maria, or this NDVC buoy, in sort of cold temperatures all the way across this past 6 months. And then looking at the actual data here, which is the black lines, the real data, and then the shaded area is the 90th percentile, with the red and blue dotted lines being sort of min-max values recorded. We can see some of the trends, again, that warm period up north, the Eel River buoy, and then the recent trend south. You see that in the data, and or trend to cold. And then at the more central coast moorings, you see pretty cold temperatures across this time, starting sort of in October. And then looking to our shore stations, and again, we've had challenges on our systems due to these winter storms and hazardous conditions, and so we've pulled from some of our NOAA partner stations to show you today. And again, just clocking some of those consistently cooler temperatures across the central coast. And then looking back, this is just the last 30 days again of real data, but that Point San Luis station, super cold, almost the coldest conditions we've seen, perhaps the coldest. Okay, so now looking at some of the glider data, so moving from temperature or sea surface temperature to really more ocean heat, and seeing some of the mixing in the top 300 meters throughout the water column, and really these warmer conditions staying offshore. Or this is back in time. Sorry, I'm looking at the plot incorrectly. So we're now in December. Yeah, there's no more of these red surface conditions, and you can see the sort of internal mixing of the system. Here again is this Monterey Bay line, looking back over the past 3 months. And then some glider data from our Trinidad Head and Point Arena lines. So these are up in Northern California. And here we're starting to see more blue colors, cooler colors, and sort of across the entire transect. You've seen these figures from our friends at Southwest Fisheries around the marine heat waves, demonstrating there's not much in the way of categorically warm or marine heat waves in the region. Looking back at some of the drivers of these things, where the browner or redder colors indicate sort of stronger upwelling, the blues, the darker the blue, the stronger downwelling signal you have. And so across the top is sort of back to May of this year. Yeah, so it's like the past 6 months. And then the bottom row is looking back to 2021 or so. So the past 6 months, you don't see much downwelling at all, somewhat neutral conditions. The monthly anomaly plots across the bottom row shows some blues, some downwellings in the latter part of 2023 and into 2024. And then these are these multivariate ocean climate indicators for Northern California. And so where you see the red dots, those are warmer conditions, typically more analogous with El Nino. Blues are cooler. And so things are trending sort of neutral right now in both Northern and Central California. All right, that's what I've put together today. Thanks again, and sorry for the technical hang up before.
Thank you, Alex. Sorry about the technical issues, but glad you were able to get that sorted out. Yeah, thank you again to all the presenters. We have about 2 minutes. I don't see any questions right now in the chat box. And I'll give folks another minute if they want to enter something in there. So thank you all for joining. And we should have another edition of the West Watch coming up in March, and you should get a link to register and a reminder for that. And I'm still not seeing any questions, so I think we will probably call it a day. And I just want to thank all the presenters again, and we will see everyone at the next edition. Thanks, Clarissa.